necessity of the nuclear power in the future energy. It's our task.
Okay. So the HTGR right now already
Yes. Yes. I will talk about my presentation. Yes, but yes, we are preparing to the restart.
Yeah, that's interesting. I think.
Yeah.
Good afternoon. Can you hear me, please?
Yes. How are you,
Okay,
Joseph?
thank you.
Okay, thank you.
Hi, Jeff. Hi, Tajo.
Hello, how are you? I'm hoping you can hear me.
Hi.
Jeff, how are you, Jeff?
Good,
Nice
good.
to see you again.
Good to see you. Thank you.
Yeah, thank you.
Nice to see you.
What time in your location, Jeff? In the morning?
Yeah, it's quite
No,
early.
no, it's afternoon.
Oh, yes, in the Warsaw afternoon.
No, it's 7:30 a.m. here.
Okay.
Yeah.
Okay. So, well, I will.
No, we have 1:30. That is early afternoon.
Okay, I will talk first using the Indonesian language to introduce to the audience. Then we will start at 7:30 p.m. Jakarta time. And in order, alphabetical order, first Dr. Shibata will talk for about 20 minutes, then Joseph, and then Jeff. So hopefully after 1 hour, we will discuss with the audience. Okay. Selamat malam Bapak Ibu sekalian. Hari ini kita mengadakan webinar terkait high temperature gas cooled reactor. Jadi ini adalah webinar kedua berkaitan dengan rencana kita mengadakan International Conference HTR 2021 di Yogyakarta pada bulan Juni. Yang pertama, first webinarnya kita adakan di bulan September. Tapi sebelumnya juga kita mengadakan pada tanggal 3 September terkait HTGR ini juga mengundang seorang profesor dari Tsinghua University, yaitu Profesor Sun Jun Liang, untuk berbicara masalah HTGR di Tiongkok yang mereka punya rencana membangun atau mengoperasikan tahun depan PLTN berbasis HTGR mereka. Menarik, kita akan melihat perkembangan baik dari Jepang. Boleh silakan bertanya, Jepang mengalami kecelakaan Fukushima tapi masih terus mengembangkan PLTN mereka, termasuk dengan yang tipe HTGR. Kemudian dari Polandia menarik terkait mereka ingin bangun 2 PWR dan HTGR. Mungkin nanti kita akan mendengarkan. Dan Pak Jeff Harper dari Amerika akan bercerita terkait perkembangan di Amerika. Kebetulan background mereka berbeda-beda. Yaitu yang pertama Pak Shibata, Dr. Shibata itu dari lembaga riset, kemudian Pak Joseph Sobolewski itu dari cenderung ke kebijakan, dan dari swastanya Pak Jeff Harper. Saya akan memulai dalam bahasa Inggris. Nanti silakan bertanya lewat menggunakan bahasa Indonesia lewat chatting, nanti kita bisa terjemahkan. Okay, I will start in English. Good evening in Jakarta, in some ASEAN region. Good morning in the United States, in the American continent, and good afternoon in Finland and European region. This evening in Jakarta, we will have the very important webinars. The second webinar towards HTR 2021. We already have the first one in September. We invited the speaker, the Dr. Futterer and Frederick Risma from the IEA. And we also invited in different events. We had already the webinars talking about HTR-PM from the Chinese, our Chinese counterpart from Tsinghua University. So it is very interesting. We will hear from different speakers, Dr. Shibata from Japan, Dr. Joseph Sobolewski from Poland, and of course, Jeff Harper from the United States. So we will hear the discussion or the presentation around 1 hour. After that, the participant can ask or maybe have a comment on the presentation of the 3 speakers. So the first one, I would like to ask Dr. Shibata to give the presentation around 20 minutes. But before that, I will read his CV. I think I have to open it. Wait.
Okay, thank you very much, Jaro-san, for your information.
Wait. I will read your CV first.
Okay. Go ahead.
Okay, Dr. Shibata is principal researcher from the Japan Atomic Energy Agency. He was graduated the master from the Hokkaido University and his doctorate from the Ibaraki University. So he is very experienced on the very high temperature gas-cooled reactor. He is also the member of technical working group on the small and modular reactors in the IEA. I think I've met Dr. Shibata several times. We discussed many things, and he also very active on the general conference to promote the high temperature gas-cooled reactor. So please, Dr. Shibata, the time is yours.
Okay, Jaro-san, thank you again for your introduction. Good evening, good morning, and good afternoon, everybody. Okay, I will share my presentation. Can you see my presentation?
Yes.
Okay. I'm Taiju Shibata. I belong to the sector of fast reactor and advanced reactor research and development. I am in charge of International Cooperation for Fast Reactor and Advanced Reactors, including HTGR. Today, I will talk about present status of HTGR development in Japan. First, I will talk about background for HTGR development in Japan. Second, outline of high temperature engineering test reactor, HTGR. Third one is progress of R&D and future plan. And finally, I will talk about summary. Promotion of HTGR development is stated in some government policies in Japan. The major one is Strategic Energy Plan. It was decided in 2018 by the Japanese cabinet. In this plan, it is shown under international cooperation, government of their use, such as high temperature gas-cooled reactors, which are expected to be utilized in various industries, including hydrogen production and which have an inherent safety. Of HTGR is stated. Third one is strategic roadmap for hydrogen and fuel cells in 2019. Hydrogen production by using hydrogen is stated. In long-term strategy under the Paris Agreement in 2019, IS process hydrogen technology is stated. Here, IS process is a thermochemical hydrogen production method by water splitting. Progressive environmental innovation strategy in 2020. IS process hydrogen production and HTGR is stated. For and hydrogen production technology. This slide shows the role of HTGR in Japan. Compared to fiscal year 2013, long-term goal is 80% reduction by 2050.
Dr. Sibal,
The bar chart shows the greenhouse gas emission
we
in
couldn't
Japan.
hear you.
It decreases gradually, but it is not enough. In 2018, the reduction is 12% compared to fiscal year 2013. We need the breakdown of greenhouse gas emission in 2018. 37% of greenhouse gas emission comes from power generation. 20% is from steel making. 18% is to be used, but also for steel making, transport, and chemical industries. So the role of HTGR is to produce hydrogen for nuclear steel making and greenhouse reduction goal. Next, I will talk about outline of high temperature engineering test reactor, HTTR. We have high temperature engineering test reactor, HTGR. The left side is a cutaway drawing of reactor building, reactor pressure vessel, hot gas duct, intermediate heat exchanger, reactor containment vessel. Major components are located under the ground. Major specification of the HTTR is shown in the right side table. Thermal power is 30 megawatt. Coated fuel particles and prismatic block type fuel element is used. Graphite is used for core components. Coolant is helium gas and reactor outlet temperature is 950 degrees C at the maximum. History of the HTTR is shown in the next slide. Conceptual design was started in late 1960s. First criticality was attained in 1998. The first full power operation was in 2001. In 2004, the first high temperature operation was done with coolant outlet temperature 950 degrees C. It was the first experience in the world. In 2010, 50 days continuous operation with coolant outlet temperature 950 degrees C was carried out. Also in 2010, loss of forced cooling test at 9 megawatt was carried out under the framework of OECD NEAR International Cooperation. As you know, in 2011, we had a great earthquake in Japan. The HTTR itself was not damaged severely, but after the Fukushima Daiichi accident, the regulation was changed. We need to pass the safety review following the new regulation to restart the HTTR. Through safety review more than 5 years, on June 3rd in this year, JAEA obtained the permission towards the restart of the HTTR by Nuclear Regulation Authority, NRA. In the safety review, the NRA confirmed core melt does not occur even in the beyond DPA. JAEA will restart the HTTR without significant reinforcement. This slide shows safety review scheme of the HTTR. New regulation standard was issued in 2013 after the Fukushima Daiichi accident. JAEA submitted the application for the restart in 2014. After the review concerning the basic design and concept, JAEA obtained the permission on June in this year. Currently, we have other review processes concerning design and construction method and operational safety program change. JAEA plans to restart the HTTR operation in July 2021. After the restart, we will carry out the LOFC project under OECD NIR. The experience of the HTTR licensing will be explained by the GIF webinar in April 2021. GIF is the Generation for International Forum. So please join the GIF webinar in the April. HTTR was designed and constructed in cooperation with Japanese companies. Mitsubishi Heavy Industries, Toshiba, Ishikawajima Harima Industry, Hitachi, Fuji Electric, Kawasaki Heavy Industry, and so on. Primary coolant system was prepared by Mitsubishi Heavy Industry. Helium-helium gas intermediate heat exchanger was by Toshiba and IHI. Reactor pressure vessel was by Hitachi. Coated fuel particles were provided by NFI. Reactor internals were by Fuji Electric. And Toyo Tanso provided nuclear-grade graphite, IG110. Chinese HTGR, HTR-PM, which is preparing operation in the next year, also uses this IG110 graphite for core components. Next, I will talk about progress of R&D and future plan. R&D on HTTR project is composed of 4 major categories. First one is based on HTTR operation. JAEA has accumulated various operation data to be used for commercial HTGR design and operation. We will continue to carry out HTTR operation tests. Second one is gas turbine and hydrogen production technology. In January 2019, 150 hours hydrogen production by water splitting with rate of 30 liters per hour was achieved. Third one is commercial HTGR design. We have several commercial designs. Major one is GT-HTR300 with thermal power of 600 megawatt. The final goal of the HTTR project is heat utilization test to be connected to the HTTR. The target is demonstration test for safe and reliable HTGR heat application technologies. We have a plan to conduct various tests using HTTR. Under the OECD NEAR project, we already conducted loss of forced cooling test at 30% power. At the test, primary coolant flow was stopped by stopping helium gas circulators. After the restart, we will carry out loss of forced cooling test at 100% power. Then we will conduct the loss of forced cooling test in which not only primary flow is stopped, but also vessel cooling system around the reactor pressure vessel is stopped. It simulates the all blackout condition happened in the Fukushima Daiichi plant. The figure at the right-hand side shows the result of the loss of forced cooling test at 30% power. The primary flow rate immediately decreases 0, and the reactor power rapidly decreases due to the negative feedback of the reactor. The fuel temperature is kept under the allowable limit. JAA has a plan to conduct many tests to confirm safety, core physics and thermal fluid characteristics, fuel and high temperature component performances, and so on for commercial HTGR system. Shown here is hydrogen production technology development in JAA. JAA has been developing thermochemical water splitting iodine sulfur processes named IS process. IS process consists of 3 chemical reactions. Input material is only water. To promote these chemical reactions, high temperature heat of 400 degrees C and 900 degrees C from HTGR is necessary. As iodine and sulfur are just circulating inside the system, the IS system only needs water and heat from HTGR. The major feature of the system is to produce hydrogen without emitting carbon dioxide. It can be said, HTGR and IS system is an ultimate clean hydrogen production system. JAA constructed hydrogen test facility several years ago, as shown in the photo, and JAA has carried out series of tests since then. All components, such as chemical reactors, pipes, and pumps, are made of ceramic materials or glass-coated metals, which can be used for commercial systems. The figure at the right side shows the test result conducted in January 2019. JAA completed 150 hours and 30 liters per hour hydrogen production operation. We continue to conduct various tests to obtain lots of data for reliability and durability of the system. So far, JAA has developed engineering materials components and confirmed controllability of the system. Experiments using hydrogen test facility and design study on commercial system are ongoing. This slide shows various HTGR systems designed by JAA. HTGR gas turbine system, HTGR hydrogen production system, and HTGR cogeneration system. Reactor power of the core is 600 megawatt for these systems. Major feature of the HTGR system is the high efficiency of the electricity generation. The efficiency of gas turbine system is about 50%. HTGR hydrogen system produce a large amount of hydrogen, 85 kilocubic meter per hour. The cogeneration system can be provide hydrogen, electricity, and low temperature heat. It can be used for desalination and district heating. The heat utilization rate is about 80%. We have a plan to demonstrate heat utilization system, such as gas turbine and hydrogen production, to be connected to the HTGR. The purpose of the project is to get the world's first licensing for nuclear, gas turbine, and hydrogen cogeneration plant, and confirm operability and complete system technology. Project plan is design, construction, and operation for HTGR gas turbine hydrogen plant. Establish new licensing framework for coupling gas turbine and chemical plant to nuclear reactor, and demonstration of key technologies. We have the HTGR, but we do not have the heat utilization system at present stage. We already finished the basic design of the system. Hopefully, JAA can get funding for the system and start this project soon. HTGR has the capability to conduct various tests for heat applications, and JAA expects many countries would participate in the test program. This is JAA's draft plan, use of HTGR for development of HTGR. Deployment of demonstration reactor and commercial reactor is expected to be done by private sectors. We expect deployment of demonstration reactor with gas turbine and steam reforming hydrogen production is in 2030s. We also expect the deployment of demonstration reactor with gas turbine and IS process hydrogen production is in 2040s. Concerning the key technology development, JAA will carry out R&D by using the HTGR. That is, operation of the HTGR to accumulate material and fuel performance data, and demonstration test of heat utilization system to be connected to the HTGR. Here, heat utilization system means gas turbine power generation and steam reforming and IS process hydrogen production. We will promote international collaboration to realize the demonstration reactors. Next, summary of my talk. Development of HTGR is stated in Japanese policies. HTGR is expected to be a promising system to reduce greenhouse gas emission from the fields of steelmaking, transportation, as well as electricity generation. JAA obtained the approval of restart of the HTGR in this June. The NRA confirmed HTGR resumes without major reinforcements due to its inherent safety features. HTTR is only reactor in the world to provide 950 degrees C heat. JAA has a plan to conduct main tests to confirm safety, physics, and thermal fluid characteristics, fuel and high temperature components performances, and so on, for commercial systems after the restart. JAA also has a plan to connect gas turbine and hydrogen production facility to the HTGR. JAA drafted the development and deployment schedule of demonstration reactor and commercial reactors. We are willing to provide our data, experiences, and so forth with international collaboration under specific terms and conditions. That's all. Thank you very much for your attention.
Thank you, Dr. Shibata. So I have, before we move to the next speaker, I have a small question. When do you think you will restart your HTGR?
Yes. So our target schedule is restart is expected in the July in the next year.
Okay.
Yeah.
Okay, thank you.
Okay, thank you.
Yeah, we will move to the next speaker. Before Joseph give this presentation, I will read his CV. Joseph Sobolewski, PhD, MBA, was graduated from Warsaw University, his bachelor's, and then his PhD at physics in Faculty of Johannes Gutenberg University of Mainz, Germany. And he has various positions right now. He entrusted with the function of advisor to the Minister of Climate and Environment of Poland on new nuclear technology and their applications. And his current position, he is also the plenipotentiary director for high temperature reactor development at National Center for Nuclear Research. He's also active in the European Council as member of the Euratom Scientific and Technical Committee. And he is also the chairman of the European Nuclear Cogeneration Industry Initiative and a member of the governing board of the Sustainable Nuclear Energy Technology Platform. So the time is yours, Joseph.
Thank you. I try to share now the screen. Okay, moment. Okay, can you see? Sorry.
Yes.
Okay, good. Moment. I have. Okay, I have some screen. My screen overhaul my screen, and that is a problem a little bit, but that doesn't matter. Okay, welcome and good morning, good afternoon, and good evening for some. And yeah, I will explain you a little bit the situation that we have now in Poland, and especially if you are looking on the title of this presentation, Poland Nuclear Energy Development, then you see two undertitles. And first is Polish Nuclear Power Program. And this is something what exists now. And this is the Polish program that was accepted a few months ago, his new update for building in Poland a big nuclear electricity generation. And the second undertitle is the High Temperature Gas Reactors Program for Nuclear Cogeneration. As you see, there is one small difference here. In the first undertitle, a program is it's a capital letter, means that it exists, really exists, is government accepted. And in the second, the program is with small letter. And this difference is that I am working now on this to establish this program as a government program now. And it's a very interesting and funny story. Okay, how is the situation when I'm looking on this? What is in the world in nuclear now? I saw that is here you have the map with the world and the nuclear power. The blue are the countries that are using nuclear power, and blue and yellow is the country they plant or the construction period. And you can see here that Poland and Indonesia are yellow. That means we are in more or less the same position. We are countries with some small nuclear activities related to research. As I read, there are 3 nuclear reactors in Indonesia, small research reactors. We have in Poland now 1, but few years ago it was also a little bit more, because before the changes from socialist to capitalist, we have in Institute for Nuclear Research around 5 nuclear reactors from 30 megawatts, 40 megawatts, 30 megawatts, and some with kilowatt power. Sorry, I have some. Is everything okay? Can you hear me? Sorry.
Yes, we are still can hear you.
Okay, good. I am still in air. That's nice. And this is the situation in Poland. We try to develop the nuclear power 2 times. This is second time that we are doing now. First, it was in 1890s, before the system changes in Poland, and it was. I had myself. Somebody, please, should unmute. Or maybe. Okay. And it was in this moment the construction based on Russian or Soviet solution related to HTGR 400 reactors. But it was the situation that in 90s, in the time of changes, it was 2 aspects that was against this continuation of this nuclear program. First, it was the politics. It was quite simple. The situation that we have Soviet Union means Russia, and that was something like a very unpleasant divorce, and the politicians don't wanted to break all connections. Second one, it was also the Polish mining sector. As you know, we have a quite big mining sector, and this time it was very important also from the, we say, social point of view, and they were quite simple against. And on the end, the first Polish power plant was stopped in 1990s. It is in north of Poland and Żarnowiec, and now you can go and see some, we say, industrial ruin, industrial museum, something like this. It was so. And we started again the discussion about the nuclear in about 11, 12 years ago, due to the situation that we have in Poland. We are a country that generate the electricity mostly from coal, from black coal and from lignite. And we know that this is in 10 years ago, 11 years ago, we after our participation or in the European Union, we saw that it is some possibilities also to change the situation. And also that was a growing problem with air in Poland, with quality of air. Also the problem with the strong dependence of the coal. That was, of course, some very important factor to national sovereignty, but otherwise it was not so clean business, of course. And we started to think about the second start to achieve the nuclear. The Poland is a nuclear country in around 2006, 2009, and 2010 was established a Polish nuclear power program. This what I mentioned at start, and yeah, and we started discussion. There is a lot of bureaucracy that you should go through before you start really to construct the nuclear power plant. Unfortunately, this is so that in European community and in Poland now, this is a really very complicated story. The European community is not very friendly to nuclear power, quite general as a whole. Of course, not the singular countries. They are very friendly, but quite general. If you are looking special of the policy of the biggest European country, the most important economic factor, Germany, there is so as it is. And as usual, this is something what is outside of Poland, but internally we have also some problems to continue this policy because our power plants, the existing power plants, they are very old. There's really the structure, the aging structure of the power plants in Poland is not very good. 75% is really over 20 years old, and this is something what is in the time today where we are looking on the emissions on the we say all green stories. We are not very clean country in the electricity generation. Of course, if you are looking on the global emission, there are some countries they are have much bigger CO2 emission as Poland, like Germany, for example. But unfortunately for us, we are this bad boy in the Europe. But this is also other problems that our biggest power plant, by the way, biggest power plant in Europe, 6.5 gigawatts in Bełchatów, it's a lignite power plant, and the resources of this lignite they are using now, they will be, we say, to the end around 2036-7. That depends from the we say finalization of this, how they will be mining this. But the problem is that the sources they are now open and they are active used, they will be quite simple out in the middle of 30s. And we should really take this into account. There are now also a big discussion in Poland to open the new lignite resources, but I think as long as we are in the European community, that is probably not possible. So the actual status is that we are over 75% we are generated from coal, from lignite or from black coal. We have only about 13% from renewables, 5% from gas, and 3% is others. There's a little bit hydro energy. Poland is a little bit poor in the hydrology, that we have not so much opportunities to using this. We have also not much gas, but we have a lot of coal, and this is why there is the situation. But it's happened something new last year. That is a new European Commission, and there is a decision of the European countries, European Parliament, and European Community to open a new policy. That is, the name is European Green Deal, and there is some targets. They are politician targets, and I am not quite sure that they are real or not real. But a few days ago, the politicians decided to reduce the CO2 emission, not 40% that was previously accepted, but now 55% by 2040. I am not quite sure how real is this. Sorry, 2030. I am not quite sure if it's realistic or not, because the politicians think sometimes that the law of physics is something that does not exist. But we will see that on the end, the situation now that we decided to change the situation in the Polish industry, generation industry, because there is, we are in Europe. We are also, we want to be in this community, and of course we want also to achieve better and more qualified life for our citizens. And we have now some project for the Polish energy policy to 2040 is still not accepted by the government as nearly ready. And here you have the main objective of this energy policies. Of course, the first is to provide energy security while we are ensuring the competitiveness of our economy, energy efficiency, reduction, and then reduction of environmental impact on the energy sector. This is very important, but it's quite general. Our long-term energy policy, this is we say 3 pillars. It's just transition. That is something very, very important due to our coal mining. It is zero emission, and of course, this is clean air, because in Poland, a lot of people, we are North European country, quite general, Central North European country, and sometimes in winter we have a very hard winter, and we need to heat. And unfortunately, there is a lot of heating they're using, for example, coal. And if the individual people using coal for heat, the emission is unfortunately not the emission CO2, there is maybe not so critical, but there is a lot of simple pollution of the air that we should leave. That we have from the pollution point of view, we are a very dirty country in Europe, unfortunately. Okay, and the plans is to develop these 3 elements. The first we want to prefer, and that was, I think, yesterday, 2 days ago, accepted the new offshore lab that should allow to develop the offshore wind on the Baltic Sea. We plan to develop between 8 and 11 gigawatts to 2040, and this is a big investment that should need to be support from the state. That is around 150 billion Polish zloty. The relation between Polish zloty and dollar is more or less as a 1 to 3.8. That is so. And the second, of course, is nuclear energy. This is the decision, and that will be I will be described detailed later. And we will build between 6 and 9 gigawatts. It is so because we didn't make a final choice of the reactors. You know, the reactors are different between 1,000 megawatts up to 1.6 gigawatts. That depends from the final decision. And this is investment we are looking that will be around 150 billion Polish zloty. And also, due to this special pollution story, we will very strong develop the localized and proximal power generation, especially not wind generation on the onshore, but the photovoltaic. And we since 2 years we have some program, and now we have nearly 1 gigawatts per year additional in the photovoltaic. This is a lot of, but of course, as you know, photovoltaic is not very efficient source of energy. And if you install 1 gigawatt, then you have more or less 100 megawatts in average if you look on the electricity generation. Of course, we are also trying to implement something like cluster. We know this cluster. This is something like self-sustainable community state using different sources, not of course nuclear, not coal, but like biogas, like wind, like photovoltaic, and also other small hydro. This is a very active now developed in Poland, and we want to have about 1 million prosumers in 2030. Sorry. Okay, now real to the nuclear, the Polish nuclear power program that I told you that was established 10 years ago, but it was updated 2 months ago due to some delays and also some decision that was made. Previously, it was fully open for 3+ or 3+ nuclear technology. Now we decided first to define how much we want. We want 6 and 9 gigawatts, and we want this installed capacity based on the proven PWR type reactors. This is decision, because previously we are talking also about CANDU, about BWR. Now we are talking only about PWR. Why? First, of course, that these reactors have a relative good history. That means Sorry.
Bye.
I have some disruption again. Okay,
It's okay now.
Okay, then there is so that there's rationales from this decision is that first, of course, we are diversified electricity generation base. We need to replace the old coal-powered power plants with something what is zero emission, but it's very important, need to be dispatchable sources. Yeah, there is so that we are looking on Germans. They have a lot of, we say, installed power 3 times bigger than they need in a maximum. But the problem is that the renewable delivered in the production, the real world, they deliver below 40% of the energy in this country. And we are looking on this and try to learn. Of course, we want also to protect the environment and climate. And this is important because the Europe is changed and want to be the most important continent from the climate safety. This is also so that we want to fill this target that we will be accepted in the future. Now they are accepted on the general European level, but for all countries. And of course, there is so that each technology has some pro and contra, but for environment, but energy mix with only renewable is unrealistic, honestly saying. And we think that it can be good mix between the nuclear power plant and renewables, and maybe some part of the fossils also. Of course, there are some economic benefits like stable price over the long period of time. We see this in France, for example, how this works. It's really quite good. And we are also thinking about some additional using of this nuclear power program to the district heating, because we have a lot of district heating in Poland in cities. And the future, of course, this is on the top. In the Europe, this hydrogen strategy, that means the hydrogen production, especially with the higher temperature, using also the heat from the reactors, what make the electrolysis more effective. Okay, these key elements of this nuclear power implementation, what I started to tell. The first, we decided that the project company that will be build this Polish nuclear power sector, it will be in state treasury with the strategic co-investor. But the strategic investor should be also connected with the technology supplier. And that will be one technology for all reactors. That will be no different reactors. It is this that we decide will be our partner, will have the opportunity to bring to Poland, we say maybe also 9 gigawatts in the nuclear power. Why technology? Why the larger PWRs? Of course, that I start to talk. There's first the most extensive experience in construction and operation of these reactors. Is in history is not so. Looking on the radiological accident, they have some history, but there is not so crucial like in other types of reactors. This is also important, especially on the level of the citizen. And there is also some reasonable common knowledge of the PWR technology by the regulators, what is important for us, because we are unexperienced quite generally, yeah. And of course, the PWR have a smaller emergency zone. The Poland is a country what we have not so much empty places, then we can put the reactor without, we say, neighbors around. And there is also a competitive supplier market, what is also important. We have now the United States, we have Japan, we have Korea, and we have France, and there is something what we can make a choice. Okay, and there is also some preliminary decision that the first reactor will be in northern Poland, on the Baltic Sea, using probably the salt water for cooling system. And the second one will be in central Poland. Of course, very often they talk about the place. There is now the biggest Polish a lignite power plant, and biggest European, by the way, lignite power plant. This is the schedule to reaching the situation. Up to end of the coming year, we want to select the technology and the partner for both power plants. Then next year, obtaining the environmental and citing the decision for first power plant, signing the agreement as you see here, and we want to start with the first reactor going in the grid in 2033, and then each 2 years we will finish the next reactors. We are now talking about 6 reactors. Probably it will be not 3 in 1, 3 in 2. There is now still something what is the discussion. The final decision will be made together with our technology supplier and the partner in this. And this is so more or less the situation that is very actual. There is also in Poland is a lot of decision and a lot of, we say, information that the people are a little excited about this. The last, we say, pool that was what the people think about the nuclear power plants give us the answer that about 62% of the Polish people, Polish citizens, accept the nuclear power as our futurable element of our futurable mix or energy mix. 62. This is a lot of in Europe. Okay, but this is the big power plants. We have also plants related to other aspects of our life. Poland is country. They have still a lot of first district heating. We have a lot of industry, also chemical, petrochemical, heavy industry, and there is a lot of needs for heat, not necessarily from electricity, but for heat. Therefore, we are few years ago discussed on the government level. I was in this time in the government that we need to look for opportunities, because we know that it will be not so fast to reduce CO2 emission in the electricity generation, but maybe it will be faster to also look to reduce the CO2 emission in the heat generation for industry. And this is very important, because now the industry used mostly the fossil fuels, mostly coal, and a lot of also gas. And gas is imported in Poland. It's not we don't have a sources of gas. And of course, there is also the question of environment, and we think there is also some very important synergy between this heat generation. This and that will be probably beneficial for both programs. Okay, the situation in Poland, and one we are looking for these new opportunities for advanced nuclear technologies, is so that we, as I told, we have still a lot of industry, and 100% of this market is dominated by fossil fuel. If you are looking on the 13 largest Polish chemical plants, we need about 6.5 gigawatts heat. Industry heat, of course, that you cannot use in this moment the traditional light water power plants, because its temperature is around 550 degrees of Celsius. And here on the right you have some small map with this industry site. And here on this simple picture you see how it is now. There is usually that because some of these industries, how of these companies, they are quite big. They're using standard more or less 160 megawatt boilers for gas or for coal. And at first, what we want to go in the direction to replace the all coal boilers with HTGR, yes, and using the gas boiler as a backup, and also as something what we can additional in the depends from the from the needs of the companies we can use it. Yes, as usually is so that the chemical process is the one place when we use this steam, but they also, these big companies, they also produce own electricity. Quite simple, is cheaper. And but this is the first target. Our first target when we are talking about the advanced nuclear technologies and HTGR is the industry heat. Of course, the secondary target is the hydrogen production, because most of these companies need also hydrogen for the production process. And this is something what you can, on the same place, you can generate heat, but also you can produce the hydrogen for the chemical processes. Okay, how is the status? We are started this discussion in the Ministry of Energy in 2016. I was in the time the director of the Nuclear Energy Department. And the first what we are appointed some committee for deployment of this high temperature technology of nuclear reactors in Poland. It was in July 2016. It was very interesting because this committee, that was over 20 people from different position, from different places. There are people from science, people from banking sector, people from industry, people from security, people from also from regulator as observer. A lot of people from Polish economy that discuss over 1 year. They working together. They publish a very interesting report about the deployment of the high temperature nuclear reactors in Poland, here on the right above. And this is also available on the government pages, Polish government pages, in the English version. It's very, very interesting. And it makes some decision. That means that was so interesting that the Minister of Energy accepted the report and took this note that this is not only desirable, but also that is more or less requested for our future. And also he requested to prepare the future steps for the deployment of the HTGR reactors. That was also some decision that this high temperature reactors will be HTGR, that means high temperature gas cooled reactors, because there is a lot of high temperature technologies. What was also important, we have some very important paper in Poland. This is strategy for responsible development that was finally adopted in 2017. Otherwise, there is known also as Plan Morawieckiego. That means that Morawiecki is the Prime Minister of the Polish government since 5 years now. And we also, this is important because everything what is innovative, if we have some from the political point of view, some deployment of this that need to be in this strategy. And it was not easy, but it was finally accepted. And the deployment of HTR for industry heat generation is in a strategy for responsible development. It's very important for us. Okay, then having this situation, we started some real work around this HTGR. We are looking and discuss with different companies, different countries. We visited also different countries and locations with HTGR reactors. Okay, there is we are visited not only United States but also Japan and in China and Korea, looking what the people have, and to go to the decision that what we want to choose on the end. And in 2020, we established also in Poland some Center for Excellence, Nomaten. There's a joint financing support from the Polish Foundation of Science European Commission. And this Nomaten should focus on the studies and development of the new materials, specifically those materials that are designed to work on the hard condition, the radiation, high temperature, and corrosive environments. And of course, everybody knows in this moment that this is high temperature technology is the first target of this Center of Excellence. And they also saw that in 2090s, the Minister of Entrepreneurship and Technology put the HTR technology on the list of national smart specialization. It is very important because it opened the way not only for internal financing but also for aid from the European funds. And okay, we hope that we can have something also from this side. But because we are looking at what we can do, we decided in the frame of some special national strategy program, Gospel Strategy. By the way, the Gospel Strategy is something what was established after the strategy for sustainable development was accepted. We opened and some new program also for innovative technologies. And the National Center for Research and Development, this organization that we have this morning, this is the source of this grant, accepted a grant for about $5 million for joint project of Ministry of Energy, National Center for Nuclear Research and Institute for Nuclear Chemistry and Technology for preparing quite general environment to deploy the HTGR technology. It is important because there is not only some technology, but this is whole environment. It's the, for example, law. If you are looking on the Polish law, that the definition of the nuclear object and nuclear reactor is the only for light water reactor. Yes, this reactor that is gas cooled is not the nuclear object, and that will be very complicated, of course, for us. This is something what we need to change, and also some internal organization in the country. There is the regulation process. There is a lot of things, especially the licensing, and this program, this Gospel Strategy, that is now in the second phase, and we are quite successfully closed the first phase in July this year. Prepare the environment for successful implementation of HTGR technology. We hope that we can close this and we can also pass this all law that is necessary from the Polish Parliament in the next 2 years. This is the situation, and what is the situation now? First, we are, as I told, we are running the HTR program, Gospel Strategy HTR, and this is preparation for deployment for HTGR reactor Poland. And we are strongly cooperate with Japan Atomic Energy Agency. I can maybe say so. This is our preferable strategic partner now, and I hope that we can, in the next year, sign some intergovernmental agreement to cooperate together. As the Tajud show on the slide, this international cooperation, this is cooperation with, and that is very important. We have also some quite general, I can say now, have also the interest of the Polish chemical industry. This is very important because they are futurable, we say, user of this technology, but maybe I coming to this program elements because they are not everything is clear for us. We are heavily working on this. What is also important, in January this year, the Minister of Science and Higher Education published the Polish map of research infrastructure contains, and this on the end is red, is very important. We are working now on the preparation of the first phase of this water program, basing on national sources of funding. That means we are not dependent from something from outside. This is our internal play. And yeah, this is maybe in the next time quite nice situation that we have in Poland, but this we need to wait maybe days or maybe singular weeks to formally announce this, that the Polish government, but this what is open now, that the Polish government will final construction of the design of the Polish version of the HTGR reactor, and hope that in the next year we can finalize the HTGR program with a big capital letter in program, bring this to the end. And the situation in the industry is very interesting, because we have this big industry is interested, but they are they usually not take the risk to go in the research part, but they are also interested, but they are interested with the final product. But there are also some important private company in Poland, Syntos, that is public, of course, that is very interested in the nuclear development, and last year they signed some agreement with the GE Hitachi to implement in Poland the BWRX-300 reactor for electricity generation. And a few weeks ago, maybe a month ago, they also signed some MOU with Ultra Safe Nuclear Corporation related to implementation in the chemical industry in Poland, the MMR reactor for this company. This is small, this is only 5 megawatts, but they are mostly interested in the heat from chemical industry. So this is the situation now in Poland, and as I told, we are now in very busy, and I hope that in the next time we can announce something positive in Poland, also in this moment in Europe, for development and deployment of HTGR reactors. Thank you very much.
Thank you, Joseph. Well, it's very interesting because you have two parallel programs, the BWR and also HTGR. My very simple questions to you. How could you convince to the government that HTGR is very important? Because Poland is new embarking countries. Usually country like Indonesia, BWR first, maybe the other technology second priority or other. Well,
no, this is parallel. This is something what I strongly hold parallel. I have nothing to do with Polish power nuclear program, and this. What is from my point of view, my main job now in Poland is to establish this program from HTGR.
Okay, thank you. Well, thank you very much, Joseph. And then we move for the next speaker, the last speakers. This is also very. I would like to read the CV of Jeff Harper. Jeff Harper is Vice President for Strategy and Business Development of X Energy United States. He was graduated the BS in metallurgical engineering, but other countries also. And Jeff Harper, as long as I know, I've met him in Vienna. We talk many things about the HTGR. So hopefully the audience
Hear me? Hear me? Okay.
Yeah. Yes.
Somewhat difficult.
Oh, okay.
Some here people can be in area. Okay. People. Okay. Okay. Thank you very much. Thank you very much. Very much. Face Twenty 25. So, is there units? He takes office. We can all expect him to pursue, he is basically consistent in his policy will be synergy. We're very goals and the Paris goal. To do and Not just North America, but they're global. We've heard not just or not just all our nuclear optimism is at X Energy. For those of you who are not familiar with X Energy, basically three different projects. For those who have it, we're not from reactor, 100 megawatts for 320 megawatts. That would be our standard. Each 80 megawatts electric. Call that the XE1. Then we have the XE Mobile, which is really focused at the defense industry, and it is a microreactor at 1 megawatt electric. We also have a commercial which produce the tricycle and the pebble form, and we're looking at and fuel. I produce back here. So try Cam, through his philanthropic interest in okay. Can everyone hear me? Okay. Again. Okay.
Oh yeah.
Actually, my turn to have difficulty, right? Really Farian started X Energy. Global Farian started and on key technical or key even more technical, Dr. on the key by 20 and more, we Situation. Couple maybe and I'll talk about all consisted of a 50% column. For the project for commitment did so we were selected with that award. They were funded also chosen by OPG, down selected with two our XE100 at the Washington nuclear power station. Actually, a close of last year. Conceptual design this time parallel so something deploying a reactor this decade. We have been working with Jordan for we were able to execute a letter of intent with Jordan for an XE100 project. Nuclear fuels in terms of looking at how they could support us with a commercial So, quick word about the leadership. Most of us have more than 30 very capable that we can achieve the goals that we set out to achieve based on the leadership. On the other hand, the organization and we are progresses and our current leaders look at retirement. These are point from government to industry, etc. So let's just talk about I'm pretty our audience here when they were basically invented before very robust history and years plus and Chinese and where they are with their programs. So very next interview really we're to and you know as soon as practical. That's really what our goal is. One and tricycle fuel particles to UCO particles and are using the UC or UC is 200 megawatts. 320 megawatts. We did a lot of market research for of this technology, as Dr. Sobolewski mentioned, is that we can get process steam at you know, in our case 569 MPa, but it opens up a number of applications, you know, water desal, district heating, petrochemical industry applications, but you know, the cherry are looking at. Also, this technology is able to load follow, which again, as I mentioned, the all above strategy with power sources, wind, hydro, and solar, we're able to load follow at 5% per minute. Our reactor ramped from 100 to 40%. So again, this is really a game changer. The fuel itself, the TRISO fuel, you know, because it's the basis for our safety case. And again, a lot of history here, and this TRISO fuel. So you know, it's well tested, it's well proven. We are looking at, you know, high burnups, you know, 168,500 megawatt per ton. And, you know, we're looking at just a super robust and just a super robust fuel. We're looking at about 19,000 of these TRISO fuel particles being, you know, almost, you can look at them independent containment. We're able to look at keeping 99.9% of the fission products within these particles themselves. You see the person up there with the reactor and the steam generator there. You know, just to say that X Energy, you know, so that we can you know, multiple commercially off the shelf components, especially, well, primarily on the side, and we're just very excited about bringing cost and time out of the plant. plant. Where we are with our generator, helical coil, steam generator design, and year design life, and again, we'll talk about the high quality, proven materials, well-known service life. That one, and again, just to reiterate that, the balance of plant health, and again, we're trying to look at how to deal with traditional issues and problems that you have in constructing these nuclear power stations. So this modularization is dealing with that. We are looking at, from a deployment point of view, an integrated production facility in terms of, components will look at having those shipped directly. They would be road transportable and can be shipped directly to the site, either shipped or road transportation. And then we're looking at obviously where you have other items and components like graphite blocks, pressure vessel heads. You'll basically store those there and ship them there and make them ready to be. So you'd have your the TRISO fuel, the commercial fuel facility that X Energy would be running, and again, fuel facility directly to the site. From an economic standpoint, that we're looking at economies of volume instead of scale. So that means we're looking at deploying fleets, and so this model is necessary for efficient not only distribution around the world as we expect to deploy, but also in again making sure that we are able to time. So here's just an artist rendition of the actual one module, and you'll see the reactor being below ground there. You have the reactor auxiliary building, and then turbine. So you're conventional island. And again, this would be an overview of the standard plant. So whereby you have 4 of these modules. So at our and you all are welcome to come when this COVID subsides. We have put up for our standard plant. We are looking at having just three control room operators. Just a word on our delivery of our first, what we anticipate to be our first commercial facility, and our timeline is 2027. Again, you can see with this aggressive schedule, we're expected to start ordering long lead items. Markets right now to the first of a kind is in North America. In the U.S., I mentioned up front, we have the Department of Energy, we call it the ARDP program, Advanced Reactor Demonstration Program. And we are looking at deploying our XE100 in Washington State with Energy Northwest. And that facility will be really not far from the current Columbia Generating Station. So we picked a site there. 2027, again, is the deployment date that we're looking at. Also in Canada, I mentioned earlier, you know, we're looking at actually the Darlington site there, whereas the date of deployment there is 2028. We've been chosen for consideration along with GE Hitachi and also with Terrestrial Energy. And you know, OPG is to make a decision approximately next year this time as to who they will go with for that particular project. This just gives a summary of what I just mentioned on the Department of Defense program. There were, in fact, nine competitors, and it was down selected to 3, X-Energy, BWXT, and Westinghouse with their eVinci reactor. Looking at you know, a winner and there'll be a demand through 2040 timeframe of about 300 megawatts. Again, our reactor here is one megawatt electric. OPG, I just mentioned OPG. And out of 10 entrants, 10 major competitors, again, there was ourselves, GE Hitachi, and Terrestrial. We're looking for a decision next year on the Darlington site. And the issue there is Canada fully expects to build a fleet, deploy a fleet in Canada, across Canada. And as I mentioned, this last one here, which is the DOE demonstration program, there were initially 37 competitors. The total project cost for us is about $2.4 billion, and so DOE is expected to contribute $1.2 billion, and it's ourselves and TerraPower are the competitors. Just a quick slide here to show at the bottom right hand, you see the dates that we're looking at. So 27 is key for Energy Northwest. OPG delivery is 2028 if we're successful with them. And for as far as technology readiness level, one thing you should take away from this slide as far as your generation 4 reactors of any technology, X-Energy, XE100 is, you know, the highest TRL level. So you would expect it to be the closest to deployment. And finally, just wanted to take a little bit deeper dive in, you know, what we expect to be our first of a kind that will be deployed. As I said, as you can see the map here on my left lower, this is Washington State, and we're expected to where you see the blue area there. That's where we intend to deploy our XE100, and we're really excited about this particular opportunity here, as quite obviously. So being the first of a kind, I think it's going to give X-energy as well as the technology as deployed in this fashion, a very big vote of confidence in the global market. If you look to the right, it breaks down pretty much what we're using capital for. You know, Energy Northwest will issue bonds and you know, basically pay for a large part of it, you know, approximately $900 million. And then X-energy is on a capital raise to cover the balance of our 50%. You know, meaning there's non-recurring engineering costs that are involved and also regulatory costs, the cost of being licensed. So I think that's pretty much concludes my talk. Apologies in advance if the technology fouled us up here, but hopefully you were able to get something out of what I've offered. Thank you.
Thank you, Jeff. I think announcement.
I'm sorry.
This project.
I can't hear anything.
The question is, HTGR is the minority among the technology on the nuclear energy. We have TWS. This is very special technology. It takes time to get a license, for example. What do you think, Dr. Shibata, Dr. Sobolski, and Jeff, about the regulatory?
About about the process. I type here
WR, for example. Now we have problem with the internet because my voice is not so clear. The participant said to me, questions to in the chat.
Oh, there's a pre-application. Application work with what's called over generation power plant, and focus specifically on high our idea for up to speed technology. If we are able to provide them with a and with simplified design, and the fact we're that education, new scale, at achieving our process. That should also
any response from about the regulatory agencies situation in about the regulatory agencies position right now, because this is well relatively minority the audio. My question to Jeff again. Can you hear a problem with the internet? Jeff, can you hear me?
I can hear you a little bit.
Yeah, I think we have problem with my audio and everyone. I'm so sorry that with the internet connection, with the problems, you cannot hear my voice clearly with the international conference in June. Thank you very much. And again, I apologize with the inconvenience of this. Thank you.
Tes. Jelas nggak ya? Tes.
That's good.
Ya. Nah, nggak kedengaran.
It's probably too much people following this seminar, right?
That's good.
People here. Terima kasih Bapak Ibu, mohon maaf, sampai ketemu nanti.
242 people already.
Tes from Yogyakarta.
Jelas.
Now is better than
Terdengar,
before.
Pak.
Nek Yojo jelas suaranya.
Terdengar, Pak.
Yeah, because maybe too much people to the participant too much. It was 290 something.
Yeah, 290 something.
No, after decreased into about 200 now, 231, then a little bit clear.
Yes.
No. Halo.
Aduh.
Pak Susilo dengar saya?
Ya, next.
Pak. Nah,
Ya,
Pak
sekarang
Wisnu
bagus
kayaknya
suara
belum
Pak
jelas
Jarod.
suaranya nih. Coba Pak Jarod, dicoba lagi Pak Jarod. Suaranya.
Yang dari Jogja jelas Pak Jarod.
Nah, Jogja bagus tuh.
Ya, kadang-kadang dari kampung lebih bagus.
Ya.
Tes.
Dari Serpong, Pak.
Ya.
Saya dari Bandung, jelas nggak nih?
Jelas, Bandung jelas. Mungkin cuaca Jakarta ini.
Bandung jelas, Bandung.
Bandung jelas ya?
Bandung jelas.
Bandung jelas, Jogja jelas.
Arigato gozaimasu.
Jakarta Serpong jelas.
Terus
Bandung jelas, Jogja jelas. Jakarta Serpong jelas.
Oke.
Bandung jelas, Jogja jelas.
Kurang bagus.
Wah, ini kalau ramai ini collision ini.
Audit.
Bicara tuh. Wah, kalau ramai tuh. Mungkin sekarang tolong di-mute dari hostnya, semuanya di-mute. Nah, semuanya di-mute ya dari host ya.